Alright, today we're in section 5.4, multiplying fractions. Multiplying fractions. Now with multiplying fractions, the rules are different than adding and subtracting because we are manipulating that denominator. 3 times 4 gives me 12, and 5 times 7 gives me 35. And the same rule applies if I'm dealing with variables. Okay, so you'll see later on in example 4 that we're going to apply our product of powers property. Remember, that property says if I have the same base, then I can do what to my exponents? What can I do to my exponents if I have the same base? I can add them or subtract them. I can add them together. So 3 plus 4 would be 7. So if I have the same base, I can add my exponents. You need to remember the product of powers property because we're going to use it in example 4 today. All right, but starting at example 1 now, I'm just multiplying fractions. And remember, the first thing we want to do when we look at multiplying fractions is if we can cross-reduce. Now, here's the most important thing that you need to remember about cross-reducing. Do not forget the sign. You see that 4 over 21, is it positive or negative? It's negative. You need to keep it negative. It's very easy to forget to keep the negative when you're cross-reducing. So 7 over 21 can cross-reduce to what? 1/3. 1/3, very good. And negative 4 and 10 can cross-reduce to? Negative 2/5. Why was it negative 2? Because it's a negative 4. You see that? And I need to keep my negative. Guys, this is the #1 mistake that I see with multiplying negative fractions is you forget to keep the negative when you reduce. So please try to remember that. Now it's just going to be negative 2 over 15. And that'll be your answer. So now we're working 7 over 10 times negative 5 over 8. I want you to go ahead and solve this one. So negative 5 and 10, did you reduce it to negative 1? Did you keep your negative? Equals negative 7 over 16. Who got that right, including the negative? Did you get it? Negative 7 over 16. All right, any questions? Does anybody have a question? All right, now moving on to example 2. Now we're multiplying a mixed number by an integer. Now remember, an integer is just a whole number. It's a fancy word for a whole number. It doesn't matter if it's positive or negative. It's just a whole number. So the first thing I need to do is change my mixed number to a what? To an improper fraction. So now it becomes 29 over 6 times, and anytime you see a whole number, I want you to automatically write it over 1. Okay, so just write it in your original problem. So if you see a whole number in one of your homework questions tonight, in the original problem, go ahead and write it over 1. And now you're just going to multiply it out. What is 29 times 7? 203 over 6. Okay, and remember we can use our calculators. We can use that function to change an improper fraction to a mixed number. It makes it a little easier, or we can do it by hand. 203 over 6 becomes what? Do you agree? Did you get that? Did you get it? 33 and 5/6? Okay, that's right. 33 and 5/6. If you leave it an improper fraction, and this is only the rule if it's all numbers. If it has a variable, you can leave it improper. But if it's only numbers, you have to write it as a mixed number to get full credit. On a test, you're only going to get half credit. On a quiz, you're going to get it completely wrong. Okay? All right, now I want you to try this next one. Go ahead and solve 6 times negative 5 and 4/7. All right, so that becomes, remember 6 over 1, we write it over 1 times negative, good job, negative 39 over 7. Can't cross-reduce anything, so I just multiply what 6 times negative 39? Negative 234. Good, negative 234. Over 7, which is what as a mixed number? Negative 33 and 3/7. Awesome. Who got that one right? I have a feeling most of y'all got that one. Good. All right, does anybody have a question? Anybody have a question about this one? Yep.
I
Okay, so in example 3, now we're just multiplying two mixed numbers, okay? So the first thing we need to do here is change them to improper fractions, and then we multiply them out. So we have, all right, so Alex, this is just like the question you were just asking. We're going to change this. 2 times 4 is 8, plus 3 is 11, and then we just keep our negative. So that's a negative 11 over 4. Does that make a little more sense? Okay. All right, times 16 over 5. Can I cross reduce? Okay, so that's where I want to ask myself, can I cross reduce? In this case, I can, which is nice. Negative 44 over 5. Negative 8 and 4/5. Think you can do a couple? You can try? I want you to try the next two. Then we'll go over them. Okay, so it's going to be it's going to be 36 over 7 times 38 over 9. I can cross reduce. Okay, what fraction did you end up with, Colin?
21 and 5 sevenths.
Okay, what was the improper fraction?
152 over 7.
152 over 7, and then that changes to 21 and 5 sevenths? Okay, do you agree?
I got 18.
You got 18?
Wait, for what? Yeah.
Okay, so what answer did you guys get? Did y'all agree with Colin? What's 4 times 38? That's 100. Yeah, it's 152. Then yeah, it's 152. And then when you divide, you should get 21 and 5 sevenths. All right, now in the last one, you should have gotten negative 96 plus 7 is negative 103, right?
Yeah.
Negative 103 over 8 times 89 over 12. All right, so, ooh, man, can I cross reduce any of those numbers?
No.
That is not fun. What's 103 times 89?
Negative 9,169.
Negative what?
9,169.
Oh, goodness. 67 or 69?
67. 67.
All right. Then 8 times 12 is 96. Then what is it as a mixed number?
Negative 95, 47 over 96. Okay.
Man, who came up with that example? Goodness gracious. All right, but same kind of concept. Same kind of concept. Change them to improper fractions, and then we're just multiplying and cross-reducing. All right, now, in example 4, this is probably the most important example of the lesson. This is what we were talking about at the beginning of this lesson with our product of powers property and how we can use it sometimes. Remember, we can multiply numbers and variables together. We just can't add and subtract them unless they have the same variable. So on the first example, is there anything that I can cross-reduce? I just want you to look at the screen for a sec. Is there anything we can cross-reduce?
3, 12.
Yeah, 3 and, wait, is 12 positive or negative? It's negative. So when I reduce negative 12, I reduce it to negative 4. It's very important that you keep that negative up there. Otherwise, you will forget, I promise you. Okay, I even forget. If I don't remember that negative up there, I will forget to include it in my answer. So now, what's negative 4 times m?
Negative 4m.
It's just negative 4m. And then 1 times 5? 1 times 5, guys? It's just 5. Just 5. Okay, now what about the next one? Is there anything I can cross-reduce? Can I cross-reduce any numbers or anything? 5 and 10, very good. 5 and 10 cross-reduces to 1 and 2. And now, look at this. Can I use my product of powers property?
Yeah.
Yes, I can, and I can because I have the same base. They're both n's. If one was an x and the other one was an n, then I could not do it. But since they both have n's, I can add my exponents, and it becomes n to the 5th over 2 times 9, which is 18. N to the 5th over 18. Okay? I want you to try the third one. Let's see who can get it. Can I cross reduce?
Yes.
Yeah, 1 and 2. And then what do I end up with my numerator?
3.
3.
And A over A fourth.
Very good. 3a to the 4th over
14.
14. All right, who got it right? 3a to the 4th. Good job, guys. Good job. All right, if you understand that, that is everything you need to know for 5.4.